In this video, we'll be talking about solving absolute value equations. Now, when we look at absolute values, one of the rules that we have for absolute values is anytime that you plug something in here that ends up being negative, it spits back that positive number. Now, it's important to note that in reality, the absolute value doesn't actually take a negative and make it positive. What an absolute value really does is it takes any positive number, so x greater than 0, and it leaves the x as it is. However, any number that's less than 0, I'm going to put equal to up here because, again, technically that is true. Any number less than 0 that's plugged into here, it actually negates that number. So in reality, the absolute value of negative 2 is not equal to 2. It's actually equal to a negative 2. Again, I replace this negative 2 with an x value, which is the negative 2, and I negate it. So really, an absolute value negates a negative. Yes, it does end up making it positive, but it's important for us to note that there are two separate cases. The case that if the inside stuff is positive, it leaves the positive stuff alone. However, if the inside stuff happens to be negative, if the inside stuff is less than 0, then we're going to negate that negative stuff. So, when I'm solving this equation, it's important that we understand that. Our first step is to get the absolute value bars by itself. I want this equation of the absolute value all by itself. Now you'll notice the 4 is not inside the absolute value. So it's not technically a part of the absolute value. Yes, it's being multiplied by it. However, you also have a subtraction of 20 sitting next to it as well. But those two pieces, since they're not inside the absolute value, they're not actually part of the absolute value. So when attempting to solve, I want you to treat that this absolute value is kind of like your x. How am I going to get this absolute value, x, by itself? Well, this will behave like it's 4 times x minus 20. So the first thing I'm going to do, and again, one unique thing when solving equations is that you actually do PEMDAS in the reverse order. So I'm going to add the 20 first because when I'm adding, that's again adding and subtracting, they're the last things on order of operations. Now, could I divide by 4 first? Absolutely, but again, that means I'm going to have to divide everything in this equation, this term, and the 0 by 4. And it's a lot easier for us to actually work with the addition and subtraction first. Get the term that has the absolute value by itself. Give me 4 absolute value of 1 minus 2x equals to 20. Then I'm going to simply divide both sides by 4. This entire term by 4 and this entire term by 4. Now, when I divide this entire term by 4, technically you could attempt to try and divide each term inside this absolute value, but why do that if we're going to treat it just like before? Keep in mind, absolute value bars will behave like a special set of parentheses. They have a very specific set of rules that is right here. However, I'm not going to distribute things into that set of parentheses. It actually makes it more complicated, and it could also make some mistakes in your overall algebra. So never just distribute anything into the absolute value. This is going to leave me with the absolute value of 1 minus 2x equals to 5. Now, at this point, we don't know what x is going to be. We also don't know what 1 minus 2x is going to be. However, if this inside stuff is positive, then it's going to spit back exactly what it is. So, in theory, this is going to be 1 minus 2x equals to 5. The absolute value will not touch this thing if this thing is positive. We don't know that it's positive, though. When we do this step, this positive case, we are assuming that 1 minus 2x is going to be a positive number. There is no way we can guarantee that. So we must account for the fact that there could be a negative case, where this inside stuff, 1 minus 2x, happens to be a negative number. And if this inside stuff happens to be a negative number, the absolute value will remove itself and replace itself with a negative symbol. So in that case, I'm going to chuck the 1 minus 2x in parentheses, because again, the absolute value is a special set of parentheses. Everything inside that special set of parentheses will end up being negated, and it's still equal to 5. Okay? Getting the absolute value bars by itself is absolutely necessary to clearly write this step out, this two-case step. So every absolute value is going to have two cases. Getting the absolute value by itself, and then the positive case and the negative case. In the positive case, we'll go ahead and solve this thing. I'll subtract the 1 giving me negative 2x, and again, don't forget to carry that negative down, equals to 4, and therefore x is equal to a negative 2. That is one possible solution to this equation. Over here, now you can distribute this negative through. But what I normally do is I ignore that this case is what's going to happen, and I jump straight down to 1 minus 2x is equal to a negative 5. Now again, in some cases you might have already been taught that it's drop the absolute value bars, negate the other side. That's all they're doing, is they're simply moving that negative by multiplying both sides by a negative 1 to this side over here. And that's actually what I'm going to do for almost every single step that I take when solving absolute values. I will now subtract the 1 on this side, giving me a negative 2x equals to negative 6, and then dividing by a negative 2. Now the reason why I move that negative over is you'll notice when I solve this secondary case, I subtracted 1 just like I did in the first case, and then I divided by the negative 2 just like I did in the first case. If you were to move this negative over, almost every single step that you do in this case as you do in this case will be exactly the same. So now I have two solutions, x equals negative 2 and x equals 3. An absolute value equation is once again another equation that you must check. They behave very similar to the absolute value, to the rational equations, where they could cause issues. So in here we should plug in from the original equation 4 times 1 minus 2 times a negative 2. Minus 20 is supposed to be equal to 0. And sure enough, if we simplify this, it's going to be 1 minus a minus, so it's going to be multiplied out as a positive 4. This will be 4 times the absolute value of 5 minus 20. Absolute value of 5 is 5. Any positive number just is untouched, so 4 times 5 is 20. 20 minus 20 is equal to 0, and that one checks. So negative 2, down here I'm going to put a check mark next to it to emphasize the fact that I did check it. Secondly, I'm going to go ahead and do 4, absolute value of 1 minus 2 times a positive 3 minus 20 equals to 0. And very carefully I'm going to simplify these steps down. 1 minus 6 inside the absolute value. 1 minus 6 is a negative 5 in the absolute value. And then absolute value of negative 5 is actually positive 5. So 5 times 4 is positive 20 minus 20 is once again 0. And that does check out. Both of these solutions happen to check, but be warned, absolute values equations have the possibility of having values that don't check. These values are called extraneous solutions. They show up specifically when there occasionally happens to be an x sitting outside the absolute value. Now this doesn't always happen, but this is the most common case where it does. So every time you see an absolute value equation, no matter what you see here, if there's an absolute value in it, you go ahead and take those values, you plug them back in, and you actually check them.